Good morning, guys. Let's keep on talking about things I do not understand. And here is something that I was messing with 24. It's basically a system that solves Fourier processing. Fourier was a guy from a long time ago, I think, in Germany. And so here, fast Fourier is used for all sorts of signal processing. And of course, I've been thinking about brain and all of this stuff. And I'll show you a thing that Fable just did for me. Thankfully, it did for me because it's very hard for Fable to have Fable do something that's brain inspired, and it sort of did it. The latest prompt actually triggered Opus on that thing, but before that, I had a Fable do something pretty cool. But so if we go back to this thing from 24, what we have here is this is Fourier processing. So Fourier processing is behind pretty much all of we have whatever graphics, audio, we have Fourier processing going on there in the background. And as you can see here in the Fourier, if you're only looking at the lowest frequencies, we get this gist, so to call it. It's kind of like what's in the image in the bottom frequencies. And if you go to the top frequencies, we see this kind of like what this is called Nyquist limit. And weirdly enough, all of this applies in BrainView, like they are talking about the Nyquist limit on the neurons, and I had some crazy ideas about that. And in the middle, what we see a Moire pattern, and Opus actually just corrected something. I was thinking that this is in the Fourier processing, this is somehow in the middle frequencies, but it's just somehow we get this. We are looking at sort of in the pattern as the different frequencies are clashing with each other. In the middle, we see this Moire. So there's this clash and whatever. And I'm not going to even talk about Fourier because it gets complicated. At some point, I understood it a little bit, but there's these arms that are kind of, let's not go there. But anyway, so this is fast Fourier processing. But so yesterday I had Fable do work on really weird thing. It was slapstack, and this was image processing. This not image processing. This was like I was trying to like build on earlier thing that I also didn't understand. So the earlier thing was called let's see. So this is a very weird thing. I think we have the entrain. So basically, what happened was that I've been working on the geometric neuron that I also barely understand well, not really much. It's just based on the perception lab accident I've described a million times. But so the in train was how it happened was that I had those ideas turn into, so I can't use the word neuron. I can't use biological words. I actually had a deep seek turn some of this stuff into remove all the biological terms and use as an AI. It's just an AI and no biological terms, no talking of theta frequencies, gamma frequencies, whatever, no talking of brain. And so I had Fable think about that result, and that ended up with slapstack. So this was kind of a sparse coding that happens in the brain. But like I was thinking, like if you have these, I think let's see, I had so what this does, I wonder if you could see it. It starts to mimic a voice. Testing. Do I have a sound on here? Testing. Oh yeah, I don't have the like we have to. I can turn it on. So now you guys are going to hear. Actually, I don't think I need to. I can turn off the speakers and you guys will hear it. Testing. So what was happening there was that we had a cochlea kind of like in the brain, and this is doing this processing, and it starts to mimic whatever is coming from the sound using sparse coding. And actually this is a Fable. This was still Fable, so it was actually what I was just explaining to you guys was from the even earlier version. So we had a, sorry guys, I'm a little bit out of it, slept long, which is always good, but this is actually, I think, no, it was even. So here we had the geometric neuron, and then we had even before that we had geometric neuron fractal, and this still was, I think. But okay, so as you guys see here, this is very brain inspired. Like and this doesn't work because I have to remove the this uses webcam if I remember right for yeah. So what you guys okay, so we have a brainstem, and the brainstem starts to grow these fractals, and these fractals, of course, they are standings for dendrites, and very brain inspired, as you guys can see. So we have a brainstem is sending one frequency, which is kind of like same as medial septum is sending out theta frequency. Then there is gamma frequency going on in the basket neurons and everything between, of course. But so we are copying brain-like ideas, but then I have to translate them into AI ideas. And what happens then when we do all of this weird ass stuff? I'll show to you guys in a little bit. So the latest thing that Fable gave me, the splat stack here. Well, I'll just show you guys. So here we have splats. This is Gabor filtering. This is what the brain does. It uses the Gabor filtering. Brain does the fast Fourier transform too on the cochlea. The cochlea has kind of like it has the kind of a what would you call that? It's there's a name for it. It's in Finnish we call it simple. It's kind of like when you have oyster, it has the spiral and then it has the hair. So that is kind of like you could almost call it mechanical FFT filtering. So it's doing kind of like what we had here in the psi image, but then the visual cortex uses this Gabor filtering. My God, these guys were inventing this in the 40s with pure mathematics, and here we have it in action. But this is two-dimensional. Of course, brain uses three dimensions somehow magically, or does it? I don't know, could be just two-dimensional field. But so what we have here is this is based on these slapstack ideas that were completely pure to me. Like I literally, I had Fable was thinking of this. It was actually yesterday and the day before, and I was kind of like, what the hell would this even lead to? I knew that it was kind of a sparse coding and stuff, and it was doing these experiments here and in the layer gate. It was thinking. And this morning I was wondering, so what is this good for? So as you guys probably get by now, I am completely like a fish out of water with all this mathematics. I've just been like, hey, do the next thing, do the next thing, do the next thing. Oh, brain has Gabor filtering. Do the next thing, do the next thing. Oh, Fable can't think about this. Well, hey, DeepSeek, translate this into text that has no brain mentioned. And to be honest, guys, the last thing when I was talking about here, this prompt through, I was just talking about the psi image. I was thinking about the system we had here, and this actually triggered Opus, so Fable could not think about it. And the reason was that as soon as Fable begins to think about the visual cortex, it has to give up because it's not allowed to think about visual cortex. So just that its thoughts led it to think about visual cortex triggered the Wars model. But before that, it met this. Now this is very familiar for anyone, as I said earlier, who has seen Gaussian splatting, so the three-dimensional splatting where you create three-dimensional splats. because these are splats here, these little mathematical floater things, and they say that brain is probably doing something like this. And this was kind of the cool thing that we got this. So we have coarse, we have mid, and we have fine, and these correspond actually, as far as I know. Brain has the V1 area, which is kind of a coarse, and then it has the mid, and it has the fine, and these are, I think this would be V1. If anyone more intelligent was following, it's kind of like there are this spinning thing, kind of like some sort of a, what was it called? It's some sort of a spin neuron, whatever. And we have the mid, and this would correspond to IT that kind of builds it all together. But the cool thing here is that without knowing that what we are talking about, we can trigger one of these splats, and we can do what those things. We can mess with its face, we can mess with its size, and so brain does something like this. How on earth have we figured that out? Who knows? We can even delete them. We can change their orientation, and you can actually see kind of like brain-like processing. Like if you take that and we are going to change its face, it's kind of rotating, as you guys see. And of course, when it's rotating, it's going to change everything else. But so brain-inspired processing after bunch of I would like to show to you guys the how we see that it's spinning. Actually, I had earlier had a really good example where I saw it spin. So I think that's kind of corresponds to the V1 neurons, the spin, the wheel neurons. There's something like it's a. I wonder if we could have there. So we are messing with individual splats here, two-dimensional splats. Nothing new mathematical here, like smart mathematicians are like, you're an idiot, and I would not deny that I am an idiot. Makes me feel like a very dumb person doing this stuff, but so okay. So the difference is that, and we can take the clips off, of course, and let's just do this. Okay, so if you guys want to use this, it's at the slab stack. There is actually a this link here. It brings you live, so you can actually you can play with it, play with this right now. You can play even without webcam, but the reason why I was reloading it was that I was messing with it. But so you can even, so you can select Gaussian splat. You can delete or lock and play with the image. But so the brain does this sort of processing, and there you saw actually one of them. Like this would be the wheel neurons, pinwheel neuron. I think it's something like that. But you saw this. You see them twist, which is super duper fun and cool and great. And what's really super duper not cool and fun and great is when your brain begins to break and it begins to do this sort of processing, and you see it. One of the main things why I'm doing this sort of stuff, because I have experienced this. And some of you guys, if you have ever tried drugs or you have, I don't know, stayed up too long, you may start to see these sorts of stuff. Of course, voters look very much like this. And this is what's happening in your brain. And we had a Fable do this sort of code suddenly. So this is kind of like what I've been doing. Why? God only knows. But so, prompt, 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 what next, what next, what next, what next, where does this lead, where does this lead, where does this lead? And we start to get this sort of stuff. What could come out of it? Let's delete a couple packages here. So I'm selecting Gaussian splat. Well, Gaussian, so details are starting to disappear. Like you guys can see, actually kind of interesting. We started to see details disappear from is it global? Like if I start removing these, are they starting to globally be removed? Like what could this be good for? Like that's kind of what I was thinking and asking from Fable. And one of the things this could be good for is that we could have very sparse video stream. Like because if you're using the fast Fourier transform kind of a video stream that is the norm, usually the thing about that is that I guess this takes more space, but when you're using just these few splats, we can get this kind of a crappy looking thing. But as proven by Gaussian splatting, I guess we could make this as sharp as we want. And but yeah. But so this is here. There's these other repos that, of course, smart people probably would not like to look at because I mean, I'm a dumbass. Why would they look at them? Well, one of the reasons might be that it's not really me doing this. It's been AI's doing it, and now Fable doing it at times, which is pretty cool. But yeah, so also, if anybody celebrated America's Independence Day yesterday, happy late Independence Day, and I hope you guys saw that. Bye.